Have you ever wondered why your internet feels painfully slow, even when your speed test says everything is perfectly fine? You pay for high-speed fiber, your download bar looks great, but your game is lagging and your web pages are taking forever to load. What is actually going on behind the scenes? The truth is, speed is only half the story. The other half is a hidden journey your data takes every single second. A journey filled with invisible intersections, hidden checkpoints, and potential dead ends. To solve this mystery, network engineers rely on two legendary detective tools, Ping and Tracert. Today, we are going to crack the code on how they work, how they are different, and how you can use them to diagnose exactly what is killing your internet connection. The illusion of speed. Before we dive into the tools, let's address a massive misconception. Most people think internet speed is a single number, but your connection actually has two main components: bandwidth and latency. Bandwidth is how wide the highway is, how much data you can download at once. Latency, on the other hand, is how fast a single car can travel from your computer to the server and back. If the highway is wide, but the cars are stuck at a broken toll booth, your high-speed internet is going to feel like a dial-up connection. So, how do we find out if the road is clear? That is where our first tool comes in. What is Ping? Ping is the ultimate digital sonar. If you have ever watched a submarine movie, you know that a submarine sends out a sound wave, a ping, and waits to hear the echo bounce back. The time it takes for the echo to return tells the crew exactly how far away the target is. The ping command on your computer does the exact same thing, but instead of sound waves, it uses something called an ICMP echo request. ICMP stands for Internet Control Message Protocol. When you type ping, followed by a website address into your command prompt, your computer fires off a tiny, virtually weightless packet of data directly at that server. The server receives this ICMP echo request and immediately fires back an ICMP echo reply. The ping tool then measures the exact amount of time it took for that round trip to happen. This measurement is called round trip time, or RTT, and it is measured in milliseconds. If your ping comes back at 20 milliseconds, your connection is snappy. If it comes back at 500 milliseconds, you are going to experience massive lag. And if it says request timed out, it means your little data packet was sent out into the void and never came back. It died somewhere along the way. The curiosity gap, pattern interrupt. Let's do a quick recap. Ping is fantastic for answering one simple question. Is this server alive, and how long does it take to reach it? But wait, what if ping fails? What if you are getting terrible lag, or the request times out completely? Ping can tell you that the packet died, but it cannot tell you where it died. Was it your home router? Was it your internet service provider? Or was it a severed underwater cable halfway across the world? If Ping just tells you the destination is unreachable, how on earth do you find the exact broken link in a chain that spans the entire globe? If you are interested to see more tricks and tips, check this video in the corner. What is Tracert? Enter Tracert, also known as Traceroute. If Ping is a simple sonar pulse, Tracert is a turn-by-turn GPS tracker that maps the entire network path. To understand Tracert, you have to understand a brilliant little mechanism built into the internet called TTL, or time to live. When your computer sends out a data packet, it doesn't want that packet bouncing around the internet forever if it gets lost. So it attaches an expiration date to it called TTL. But TTL isn't measured in seconds. It is measured in hops. Every time your packet reaches a new router or intersection on the internet, which we call a hop, the router subtracts 1 from the TTL. If the TTL reaches 0, the router destroys the packet and sends a message back to you saying, "Time exceeded." Tracert uses this destruction mechanism to its advantage in a highly clever way. When you run Tracert, it doesn't just send a packet to the destination. First, it sends a packet with a TTL of 1. That packet travels exactly 1 hop, usually to your home router. Your router subtracts 1, the TTL hits 0, the packet dies, and your router sends back a time exceeded message. Boom. Tracert just recorded the exact IP address of your first hop. Next, Tracert sends a packet with a TTL of 2. It passes through your router, hits the next router at your internet service provider, dies, and sends a message back. Boom. Tracert just recorded the second hop. It repeats this process, increasing the TTL by 1 every single time. TTL 3, TTL 4, TTL 5. Hop by hop, router by router, it forces every single checkpoint to reveal its identity and its response time until the packet finally reaches the final destination. It is like going on a cross-country road trip and forcing your passenger to text you their exact coordinates every time they pass a gas station. By the end of the test, Tracert gives you a complete, step-by-step map of the network path. Ping versus Tracert, the powerful comparison. So, let's put them head to head. Ping and Tracert are both diagnostic tools that use ICMP, but they serve two very different purposes. Ping is your quick health check. It is fast, lightweight, and perfect for answering, "Are we connected?" You use Ping when you want to check if a website is down or if you want to monitor your average latency while gaming. Tracert is your deep dive autopsy. It is slower and more methodical. You use Tracert when Ping fails. If Ping tells you there is a traffic jam, Tracert tells you exactly which intersection has the accident. Practical use cases and viewer question. Let's look at a practical use case. Imagine you are trying to stream a movie, but it keeps buffering. You run a ping to the streaming server, and it shows massive delays. Next, you run a Tracert. You look at the results and notice that hops 1, 2, and 3 are lightning fast. But at hop 4, a router owned by your ISP, the delay suddenly spikes to 400 milliseconds. You just proved that the problem isn't your Wi-Fi, and it isn't the streaming service. Your ISP has a congested router, and you have the data to prove it when you call their customer support. Now I want to hear from you. Have you ever tried to diagnose your own internet issues using the command prompt? What was the most frustrating network problem you've ever had to solve? Drop your stories in the comments below. I read every single one of them. So, understanding the invisible world of data packets gives you the power to stop guessing and start troubleshooting like a pro. Ping tells you if the path is clear. Tracert maps the path for you. If this video helped you crack the code on how your internet actually works, hit that like button so this knowledge can reach more people. Make sure you subscribe and turn on notifications because next week we are diving into how hackers manipulate these exact same protocols. You won't want to miss it. Thanks for watching, and I will see you in the next one.